We showed 13, right? In last class, the 13 tell you moles, 5.1 moles sulfur. Ask you how many sulfur atoms. You remember this? So from moles to number of particles. So I used to be right in that corner. For that corner, I do it. Mass, the moles, mass is a m, lowercase m to moles is mass divided by molar mass. If we know moles, back to mass is more multiplied by molar mass. And for mole to number of particles, these particles could be atoms, could be moleculars, depends on your substance. Some matters in format of atoms, some substance like carbon dioxide in the format of molecules. So either atoms or molecules, because this is atom. So more multiplied by Avogadro number. So Avogadro number is this number, 6.022 times 10 to the 23rd for more. Right? If we know more number of particles to figure out the moles, then number of particles divided by Avogadro number. So this chart is very important. Okay. So this is we showed in last class, 5.1 more sulfur. How many sulfur atoms? So clearly it's a more multiplied by Avogadro number. Right. Use your calculator. Use your calculator. You just use calculator to figure out this regular number. Exponent number, don't put it in the calculator. It makes you easier. Calculator will give you 30.7 times 10 to the 23rd. 5.1 times 6.022, 30.7. Then you need more one decimal place because this is greater than 10. 3.0107. Okay, you move one decimal place, become 3.07. This means you times 10. The 10 is 10 to the 1. Plus here is 10 to the 24. This is we explained in last class. The next one. Ask you how many grams of gold are there in 15.3 more? Gold. How many grams? So according to this, here you moles, right? Ask you how many grams, that is mass, right? So mass multiplied by molar mass. What is molar mass of gold? You need to use periodic table. For gold, 196.967. You can simply use 197. Okay. Now, we need that one. So, more multiplied by molar mass, 197 gram per mole. Right, more answer per mole. You get a mass. This is 3014.1 gram. Or you can neglect the 0.1, just 3014 is fine. Okay, so more back to mass is more multiplied by molar mass. We find the molar mass with the help of periodic table. Okay. Number 52. Here you empirical formula. is CH, C1H1, and tell you molar mass of this compound is about 78. So based on these two conditions, ask you molecular mass. And molecular formula. From molecular formula, of course, we can find actual molecular mass. So tell us empirical formula together with the molar mass of molecular formula. Ask us what is molecular, together with molecular mass, ask us the molecular formula. So first of all, we need to understand the difference between molecular formula and empirical formula. Okay. So empirical formula is a symbol is the whole number ratio of each atom from element. Right? Molecular formula exact number of atoms from each element. Their difference is a whole number. Right? If empirical formula, molecular formula are the same, that number is 1. Okay, so we can imagine molecular formula will be looks like this: either CH or C2H2 or C2H2 or C3H3 or C4H4, C5H5, C6H6. Looks like this, right? So we need to figure out what the number is. Well, can you understand? If empirical formula is CH, then molecular formula could be any of this. Can you understand it? Our job is to find the actual number is 2 or 3 or 4 or 5 or even 1. This is our job. Can you understand this? Okay. Then our job how to find out this number. Since here tell us we already use this condition, right? From here to this we already used. Then you need to use the other condition. 78 gram per mole is for molecular formula's molar mass. Then what is empirical formula's molar mass? Then we compare these two, we can figure out this number, right? Molecular formula's molar mass is 78. Then what is the empirical formula's molar mass? Empirical formula tell you, right? 1 carbon, 1 hydrogen. Use the periodic table. Carbon is 12. Hydrogen, 1, right? This is the empirical formula's molar mass. So 78 divided by 13. What do you get? You find as the closest whole number. Clearly it's not 1, and not 2, not 3, not 4. How about 5? No. 5 is 13 times 5 is 65. 6. 6 times 13. Exactly like 78. So this whole number is 6. For this whole number 6, then clearly molecular formula will be C6H6, right? CH times 6, C6H6. Right. You get it? Okay. This relatively easier, or these 3. And to show you next one will be harder. So most of you will be prefer this is harder. Okay. The reaction is between resin and nitrogen gas. Lithium 12.3 gram. Nitrogen gas 33.6 gram. And I tell you, actual yield is 5.89 gram. Actual yield always tell you. First question asks you which one is a limiting region. Okay. Then second question asks you the percent yield. So we need to answer first which one is a limiting region. Ask you which one limiting region is either this or this. Always written. Cannot be product. This is the first thing you need to understand. Whenever ask you which one is a limiting region, always written either this or this. Cannot be product. Okay. Then how can we figure out either lithium or nitrogen? So we can pick any one of these two to figure out how much of the other one needed. So if we pick this, of course you can pick this. This is the same. Format is same. Now methods are similar. Your answer also will be same. Whichever you pick doesn't matter to your answer. Okay. If 12.3 gram lithium are reacted, we can figure out how much nitrogen needed. Going to use this balanced equation. Okay. So 4.3 gram. This is a mass. Mass always converted to more because this is a more relationship, right? Balanced equation is a more relationship. How can we convert mass into more? Again, this chart. Mass divided by molar mass. What is the molar mass for lithium? Use periodic table. 6.94. So 6.94 gram. One more lithium. All right. So mass divided by molar mass. So gram, cancel this gram. Left over more. Then use this balance equation. Every 6 more lithium need 1 more nitrogen. Okay. You put 6 here or 6 here. We want to convert more of lithium to more of nitrogen. Right? We want nitrogen. So nitrogen in top. Lithium, sorry, nitrogen in top. Lithium in bottom. So in this way, lithium will be considered. We convert lithium into more of nitrogen, right? This is what we want. So up to here, we get more of nitrogen, but here tell us is not more. This is mass. So now we need to convert more back to mass. More back to mass. Right. More multiplied by molar mass. So we need to multiply by molar mass of nitrogen. More in bottom, cancel this more. Mass in top. Nitrogen, use the periodic table, is 14, but this is N2. 14 is just for N. So 14 times 2 is molar mass of nitrogen gas. Get it? This more cancelled, we get mass. Use your calculator. 12.3 divided by 6.94 divided by 6 multiplied by 28. 8.27 gram. So this is nitrogen needed. How much we have? 33.6. gram nitrogen is the amount we have. Right? We only need 8.27, but we have 33.6. What does this mean? Yes, nitrogen is excess. Nitrogen excess, the lithium is limiting. Are you okay so far? Okay, so you may wonder, if I happen to pick this nitrogen, is the answer same? I can assure you, the answer will be same. If you pick nitrogen, then you just follow this. So nitrogen mass divided by nitrogen's molar mass, get more. Then times 6 becomes more of lithium. Then multiply by lithium's molar mass will be mass of lithium needed. That mass, I'm sure, will be greater than this 12.3. Greater than 12.3, that means lithium is limited. Not enough, right? We need more than we have. This means lithium is not enough. So lithium is limiting. Answer will be same. Okay. Now we can calculate theoretical yield. Whenever you have limiting reagent, we can calculate the theoretical yield. So now you have to use limiting reagent. You don't have a choice now. Okay. So 12.3 gram lithium. First, convert mass into mole. It's always. 6.94 gram lithium. Okay, convert mass into mole. It's always because the balanced equation is more relationship. Then use the balanced equation. Every 6 more lithium only produce 2 more lithium nitride. Your question is, you put 2 more lithium nitride in numerator or in denominator? I'm putting the wrong place. This is critical. Okay. Since we want to convert more of lithium into more of lithium nitride, of course, more of lithium nitride in the top. Okay. So more lithium nitride in top because we want this. Okay. And more of lithium in bottom. So more of lithium can cancel this. Right? So we get more of lithium nitride. So yield, theoretical yield or actual yield always mass, not more. We need to convert more to mass. More to mass. Right? So multiply by molar mass. What is molar mass of lithium nitride? Then we need to use periodic table again. Okay. So you have, for this formula, you have 3 lithium. Each lithium is 6.94. 1 nitrogen is 14. So 3 times 6.94 is lithium. Plus nitrogen is 14. This is molar mass. Okay, from here we get a mass. Now use your calculator. 12.3 divided by 6.94 times 2 divided by 6. then multiply by this. Anyway, use your calculator. I cannot figure out the exact number. This is multiply this number. You get the theoretical yield will be 20.57 gram. Okay, so theoretically, if 12.3 gram lithium or reacted, we expect 20.57 gram lithium nitride. Then we can calculate percent yield together with this actual yield. So percent yield equals to actual yield divided by theoretical yield times 100%. Actual yield always tell you, this need a wrong experiment. You cannot calculate. Okay, so don't worry in the quiz or test. This always tell you. So here tell you, actual yield is 5.89. Theoretical yield we just calculated 20.57. Then use calculator, you can easily get this percent yield is 28.6. Okay, because this is 3 significant, so answer keep 3. Okay. Are you okay for this? Okay. Do you have other question? No? If you don't have any other question, then we